Hello and welcome to 5.3 Scatter Plots and Lines of Best Fit. So today what we're going to be doing is we're going to be taking what we've seen in 5.1 and 5.2, so with our slope-intercept and our point slope, and we're now going to kind of, in a sense, be applying it to the real world. So a scatter plot is literally what it means. It's a scattering of data. You should have seen them at some point before this class. What we're going to be doing more, though, focusing on is a line of best fit. What it is, it's a best line that fits all of the data. And it indicates how well a particular set of data can be approximated by a straight line. So we have types of correlation. So this first part of the video is going to be a lot of vocab. We're going to learn 7 new vocab words. So the first one is a positive correlation. So this is when the points on a scatter plot can be approximated by a line with a positive slope. And so what it looks like is, a bit bigger, is it's a bunch of data points that create a line that's going up. And so a line of best fit, when we would draw it in, it would look like this. And that's why it would be a positive correlation. Now a negative correlation, when the points on a scatter plot can be approximated with, guess what? A negative slope. And so our data is going down. And so it looks like this. And so again, when we put our line of best fit in, our line would be going down. That line of best fit, I'll identify this as a line of best fit. It just approximates all the data. What we're going to be doing is we're kind of, in a sense, going to be smushing all the data to create one line. And our last one, no correlation, when the points cannot, when the points on a scatter plot cannot be well approximated by a straight line. So like they are all over the place. You can't make anything out of it. Now, we're going to be focusing more on a linear correlation, but there are 3 other types of correlation. There's actually more, but we're going to just talk about 3 new ones, and these are going to be the ones we're going to talk about like in the whole school year. So linear correlation, guess what? It creates a line. And so our data would look something like this. And so how we would explain this type of correlation is it would be a, it's going to be a strong, we'll talk about that more in the later, strong, negative, linear, okay? And we're going to be talking about that later, but those are all the words that we can describe this linear correlation. It's linear because it forms a straight line, and it's negative because we would have a negative slope. Our exponential, this is a J-curve. You should have seen it at some point in science class. And so it starts out small, and then it grows very quickly. A quadratic, we're going to learn more about quadratics next semester, but it's a U shape. It doesn't have to go through the origin, so it can look something like this. And that would be our quadratic correlation. So, how we find a line of best fit, there's actually 3 ways. This first way is by your brain power. So you plot all the data points. This is always going to be. Then we use a ruler and draw a best fit line through the data points. Okay, this will always be the same. This is where it's going to change, okay? I'm going to just draw a line. So we find 2 points on your line that can identify X and Y coordinates. So we're looking for a lattice point. Remember, that's where it crosses your graph nicely. And then using those 2 coordinate points, do the 3-step process. We find slope. Then we use point slope because we now have a point and a slope. intercept form, or point slope form, to write the interim equation, and then we rearrange it into slope intercept form to get y equals mx plus b. So we're going to graph the following coordinates and draw a line of best fit. I would suggest that you pause the video so that way you can copy the data points down. All we're doing is taking this and graphing it over in this area. I did draw in a new x-axis because it kind of got printed weird. Okay, so how we draw in our line of best fit is we take our ruler and we kind of just put it in the middle of all of our data. It's just an approximation. And so this is my approximated, I'll put it, approx line of best fit. The reason we draw this is that it can tell us that we have a linear correlation that is positive. And so what we're going to do is we are going to now find any 2 points. So I'm going to pick the 2 points. So 1, 4 and 6, 10. I picked these 2 points because they create that slope. They're kind of far apart. 1, 4 is right here, and 6, 10 is over here. It kind of spans almost all of our data. Okay, and my line goes through. Okay, so using those 2 points, my first step is to find my slope. So we're going to do 10 minus 4 over 6 minus 1, which gives us 6/5. Our next step is to do our point slope. Again, we have a point and a point, 1, 4, that's the one I'm going to use, and my slope. So y minus y sub 1 equals my slope times x minus 1. Now we're going to go into our third step. I'm going to clear my fraction in the process. So that means I'm going to multiply everything by 5. Now might not always have to do this, but because we have a funky fraction, I'm going to clear it out. So I'm going to multiply everything by 5 to get 5y minus 20 equals 6 times x minus 1. You could probably have also distributed this at this point. And so we get 5y minus 20 equals 6x minus 6. And now what I'm going to do is I'm just going to get it into slope-intercept form. So I'm going to add 20 to both sides to get 5y equals 6x plus 14. And then divide everything by 5. To get y equals 6/5 x plus 14/5. And that would be our line. And we can kind of look at it. Oh, well, we go up 6, right? 5, okay. 14.5 is approximately 2.8, which, look at that, 2.8. So the line I drew is pretty good. And so what we can do is, because this is an actual equation, we can use this to predict the future. And we're going to talk about that on the next page. So on the next page, we have snowfall records in northern Michigan. So the table below shows the snowfall records measured in inches near the airport by the Michigan Tech Keweenaw Research Center over the past 14 years. We're going to use this data to create a scatter plot and answer the questions below. So as you can tell, I already graphed all these points. So if you want to take a moment and pause the video so you can copy them down, you can. But I'm going to keep going. So our year. We actually are missing some important information in this data since we're working with real world things. We would want to label our x-axis in years, and we would want to label our y-axis in snowfall. So I'm going to put snowfall. I know that's our title. And so this is why we're going to put inches, so we know what we're working with. Okay, so now what I'm going to do is I'm going to bring in my ruler, and I'm just going to kind of guesstimate where, like, it's in the middle of all my data. And I'm going to draw, what is going on? draw in my line, and that would be my approximated line of best fit. Okay, and so because of this line, it is a linear, because it forms a straight line, and it is negative because the line goes down. So, what is the equation of the line? I told you there's three methods. How we got this one is we are going to use our calculator. So for right now, I'm going to pick two lattice points. So I'm going to pick 2010, 132 and 2001, 254. The reason is, again, they kind of represent the spread of my data. Okay, we don't want them really close to each other. We want them on different lines. And so using those 2 points, so 2011, 132 and 2001, 254, we would use our calculator, which is going to be in a different video. We would get an A value that is negative 12.2 and a B value, which is 24,666.2. Once we have those, we can plug it into y equals ax plus b, our slope-intercept form. So y equals negative 12.2x plus 24,666.2. That is our line of best fit using our calculator. And so the reason that we want a line of best fit is we can use it to find more information. So if this pattern continues, how much snow should northern Michigan expect this winter, 2014? Well, let's look at our table. Well, 2014 is a year, and year is our x values. So what that means is we're going to plug in 2014 in for x. So y equals negative 12.2 times 2014. We don't change the year because we didn't tell our calculator we're starting with 0. Plus 24,666.2. And what would happen is we would get 95.4. Now, because this represents a real world thing, what is that output? Well, what's our y value? Snowfall in inches. So we can put inches as our unit. So we would expect that in 2004, based on our line of best fit, which is also called a trend line, based on our trend line in 2014, we should approximately get 95.4 inches. And then next winter, so x equals 2015, we're going to do the same exact thing. And we are going to plug in 2015 into our x value, and then plug that whole equation into our calculator, and we would get 83.2. And again, we would write inches because it's asking for snowfall. Now, the last question, do you think these are reasonable expectations? So let's look at our graph. 95.4 would be about here. And 83.2, that'll go here. And 83.2 would be right around here. Well, they're pretty close to my line of best fit that I approximated, so it's not really accurate. But is it on trend? Like, it's going down. It's pretty good. So yes, because the values are decreasing. And they're close. Oops, wrong there. There they are. Close to our line of best fit. So our last method that we're going to use to create equations is on a computer that we will do together.